Hey friends, Nick here with another edition of the old weather wall where I stand at a wall and talk about the weather. Today's topic is cloud formation. How the heck do we even get a cloud to begin with? Well, it takes three things. It takes forcing or ascent, and that's just basically putting air where it doesn't necessarily naturally want to go, or conversely, moving air naturally where it wants to go. The temperature must equal the dew point, and we can't have any advection of any other kind of drier air into where we are making that cloud. Advection is just the horizontal move. You probably heard of a convection oven. This is just a different kind of vection. It's advection. It's basically wind. It's a really fun word for wind. You can impress your friends and say, I'm going to advect my way to the mailbox. It's just horizontally moving to the mailbox. All right, so let's start out with forcing and ascent. Now, forcing can happen along a cold front. So let's say you've got a big wall of colder air that's moving this direction. All of this cold air is going to be pushing its way into a place where the air is warmer, and that's going to force that air to move upward, and eventually it moves up high enough that the temperature equals the dew point, and you end up with a cloud. And I wanted to stop right there real quick. There's your fun cloud. The temperature equals a dew point. This becomes really important. If the temperature outside in the summer is, let's say, 95 degrees, the dew point is probably, if you're along the Gulf Coast, put a little degree symbol there, the dew point is probably somewhere around, let's say, 75 degrees. Well, a difference of about 20 degrees. So that's we call it a temperature dew point depression of 20 degrees. So you've got to go up in the atmosphere, and you naturally cool things down. So you've got to go up far enough that the temperature equals the dew point. And that changes on any given day, and that will change as this temperature changes, and the temperature and dew point relationship changes. And before I go any further, the reason this becomes really important during severe weather season is tornadoes and all kinds of severe weather is, let's say the temperature outside is, I'm starting to lose my pen, is 71 degrees and the dew point is 67 degrees. You may not have to go up quite as far to reach a point where the temperature equals the dew point, and then you can form a cloud a whole lot lower. Well, if you're trying to make a tornado, which do you think, sitting at home, is easier? To make a tornado that's super duper long or make one that's a little bit shorter? I mean, that's kind of a no-brainer. You don't have to be a meteorologist for that. And sure, I know there's going to be some meteorologist or weather enthusiast that watches this that says, no, 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 there are situations where it's easier to get a tornado that's really long versus really short. Yes, I absolutely agree. But generally speaking, it's easier to make a shorter one than it is to make a longer one. And that's where this temperature dew point spread comes into play. That aside, let's get back to talking about cloud formation. So we've got the forcing of a cold front literally pushing air in a place where it doesn't necessarily naturally want to be. You've also got ascent. That's the natural movement of air into a place where it wants to be. For example, if you move up above where we are, and let's go up to about 25,000 feet. The air here may be at a temperature dew point spread, let's see, at 25,000 feet. Let's do negative 10 degrees temperature and a negative 13 degrees, let's say, dew point. And so it's drier than the temperature. Remember, because we're negative at this point. So if we were to naturally lift this air, just because the pressure aloft is a little bit lower and high pressure always goes toward low pressure, we may reach a point where this lifts up where the temperature is negative 13 and the dew point is negative 13, and you end up with these kind of wispy clouds up really high in the atmosphere, which are generally, as you can imagine, ice crystals. They're not actual physical raindrops usually. And so that's what happens when we get up and we're talking about natural ascent. And that's usually pretty slow. It takes a long time to do, which is the other reason why you end up with ice crystals and not raindrops, because we are very slowly cooling down that raindrop. And then we can't have advection into the cloud. So let's draw ourselves another cloud. We'll build a nice, ugly cumulus cloud. I was obviously not an art major. if we were to blow some dry air into here, we would erode away at that cloud ever so slowly. This can also happen when a cloud maybe rains itself out. It precipitates itself out and it starts to dry out, and you start to entrain some dry air in here, and that'll erode away at the cloud. And you've probably seen this in the summertime or in the spring. You've looked out on the horizon and you've seen this big puffy cumulus cloud, and then slowly it just evaporates into nothing. That's because you started advecting some drier air in there and basically eroding away at the side of the cloud until there was no real cloud left, and pretty soon it was just maybe a little cloud like that with absolutely no rain falling out of the bottom of it. So again, forcing an ascent, the temperature must equal the dew point, and we can't bring ourselves some dry air into our cloud, or else that's going to kill it, and then we are no longer talking about, well, cloud formation.